I use a simple dipole kit for portable or temporary antennas. I made the first version over 40 years ago, and it's been through a few iterations since then, but they work well, and I've used it for a number of other antennas as well. It's been used with loops, ground planes, and beams. You'll see some of these in my other videos. I started with some requirements for it. I wanted to be able to use it for dipole antennas over the whole HF range. And I wanted it to be adaptable enough that I could use it for other antennas as well. I wanted to be able to add multiple bands at the same time, so that I could set it up once for multiple bands or just for a single band, depending each time I used it. Basically, I wanted to be versatile and adaptable so that I could use it in a lot of different situations. What I came up with was a dipole center insulator connected to a length of coax. And then I carry the wire elements separately and put them on in any combination as appropriate. Another important point is strain relief. This is a common failure for antennas. I didn't want any stress on the electrical connections. With thin wires, the insulation actually provides much of the strength. And so I wanted to put the stress on the insulated part of the wire and not on the bare end. The simplest version just uses a piece of plastic for a center insulator. This T-shape is a convenient way to cut up a bunch of PVC lattice, which I happen to have extra of. The wires tie through these big holes for strain relief and then connect under these wing nuts. That provides the strain relief so there's no tension on the connections. The coax is connected under, there's a second bolt on the back side. Those are on different sides so that I don't scrape my fingers on one when I'm doing the other. I learned that from experience. The coax is connected under the two bolts, and for strain relief it passes through two holes with a tie wrap to hold it in place. And then it has a loop of rope to hang from. And that's basically it. Typically I use these with 8 to 15 meters of cable, 25 to 50 feet, depending on the application. The wires are carried separately in individual bags, each one marked with the frequency band that it's for. Now, you don't have to use color-coded wires for the different bands, but I find it works better to avoid making mistakes in the field. If I want to use the antenna on multiple bands at the same time, then I just connect multiple wires to the dipole center insulator and connect all the ends under the wing nuts. If I'm only going to use one or two bands for a given trip, then I just leave those wires connected to the center insulator. I use stranded insulated hookup wire for my antennas. Typically 1 millimeter, that's American wire gauge AWG 18 gauge. Though for backpacking I might need to go down to 0.4 millimeters or the number 26 wire. Usually these work well without a balun, most of the time, but I have experimented with adding a balun to them. This one has two ferrite cores, one on either side of the insulator, with a piece of thin coax passing through them. On this version, I tie loops in the wires and then hook them through these miniature carabiners to it. I do not use the carabiners to make an electrical connection, but that provides my strain relief, and then the ends of the wires go under here. That's a little faster to set up each time because I don't have to retie the knots in the wires. This is my original backpacking kit from over 40 years ago. It's made using a slice of radiator hose, and the wire is just tied through the hose and out to the sides, and then the ends fit under these thumb nuts. And it also has the little rope to hang it, because very often I install these as an inverted V. This one's been halfway around the world over that time, and it still works well. This is a newer version for backpacking. It uses a coax similar to RG316. It uses these small lanyard clips to attach the wires to. And in addition to the wing nuts, I've added these fawn stock clips. That's 1920s technology. Actually, I find they don't work as well with stranded wire as they do with solid wire, but sometimes they're useful. Otherwise, it's basically the same design as the others, just constructed a little bit differently and smaller and lighter. There's no magic in any of this. You can build something similar with commercial insulators. I just happen to have pieces of plastic handy. If you keep the basic principles in mind, you can probably come up with an even better design that suits your needs. Adjust the details for the materials you have available and just go out and use it. It certainly has made things a lot easier for me in experimenting with antennas.
For more information, visit practicalantennas.com.